So good morning. This seems to be the last talk in this morning session because before we go into the panel session discussion. So I try to make this one short, and we try to have the discussion just right before the panel discussion. If you want to have any questions, feel free to raise your hand during my presentation. And if I have any question to be answered right then, I try to answer. Otherwise, I try to ask my friends or other experts to help me, to save me, okay? Let me try to play this one. Anyone can save me? Yes, good. Okay, so the talk to be assigned to me to be presented, that is the application of computer vision for smart environments. And some of you guys already attended the similar talk in the TED Talk from with AI in November this year. So your question might be, what is the difference between my previous presentation and this one? The first thing is the previous slide have the different layout, right? Looks in here, maybe it is nothing different. In my presentation, there can be multiple images and video clips, but I will not give any specific message in the slide. I would like to discuss with you, and we try to find the message throughout my presentation. So it can be the same material, but we can discuss on different topics. So the first thing, I would like to share with you my passion 10 years ago. When I finished my PhD degree, actually my PhD thesis was in cryptography and block ciphers. Nothing to do with computer vision or machine learning at the time. And then one of my friends, Mr. Steve, he's sitting over there. I try to ask him to follow me, or I follow him to do something crazy. And what we try to do is to make the interactive environment to be smart, so that you can interact with different objects of the computer in a different way, that you love to do that in a fancy way, or similar things like that. And I would like to show the demonstration from Steve and his colleagues, let's say 8 years ago. We just watched the movie from Tom and Jerry, and we see an invisible mouse. So in here, we just say I don't really have any physical mouse. I just use my hand and move around over the surface, and we can easily track where the finger, and we can try to simulate the event in the computer. This is invisible mouse from Dave and his friends in 2010. And we developed the multi-object tracking for augmented reality. But at that time, we don't really use something like Vuforia or similar technology. We do it by ourselves for tracking using the regular machine. It's 8 years ago. The next one, motion capture and facial motion capture, and also vision-based multi-texture surface to be developed by students in the library last year in the university. Just try to do it. We don't really care about this one already developed by other researchers in the world. We just do because the students love to do that and try to do from scratch. And you can see in here for the motion capture, we don't really have something like a very high techniques to be applied then. We just try to get the information from the RGBD in the very first version of Connect version 1. And we link it to different zones. We don't have any information for skeleton. We just apply and move different zones depending on the information captured directly from RGBD at very first version. So that is the beginning. So I would like to share our passion in our research group for smart environment in which people can have better way for interaction, fancy way to interact, and what we need to do, we need to learn. We learn different techniques in order to realize our ideas. So we need to learn anything that is accessible for this one. And today my talk is about live logging data and how we can take advantage of this huge amount of data every day we capture to provide better understanding for our lives and can serve for you for different services and utilities. Okay, so just look into this picture and you can see this one. I've just taken this picture during this event this morning. And you can see different of your friends in here. This one was taken today And next year, when we look back into this picture, maybe you want to recall the memory of the story behind this picture. One. One of my friends, I'm very lucky to have one of my friends who lived with me in high school, and he is here to attend. And we're to share the photo of our class in high school. Maybe we have a lot of stories or memory related to this picture when we look at this picture. And Hoa, can you recognize your face in this one? During dinner, you invite us when you arrive in Utah, right? Yes, thank you very much. Then, so every picture, every moment in our life has its own story and message. And how can we exploit the insight understanding? This is the main message I want to share, the very first message I want to share in my talk today. So what is the live vlogging data? Everything you capture, even for the live streaming video we are watching on Facebook right now, it can be the source for exploiting insight understanding of different things. In Vietnam, we usually refer to smart city. Every day you can look everywhere and you can see the word smart city. And we really need smart citizen for three main tasks. The first one, who can exploit smart features, utilities, and services. We have smart service, so we must have smart citizen to utilize those things. The second one, we should contribute the information back into the system to make this one smarter and learn day after day to make the system to be smarter. And the last one, we need experts to develop services and utilities to provide other people to use. So we have multiple sources of information that can be exploited every day. We have public system to collect information. It can be from public surveillance system, cameras, even in a supermarket. But we also have the private or personal systems that we use every day. It can be GoPro that can be mounted on your shoulder or in your head to capture every moment of your life. It can be something like the wearable cameras like this you wear every day to capture the information. We also have multi-other sources, photos on Facebook, YouTube channel, and text you post or you like on Facebook. Those channels can be exploited to provide insight understanding. So now we move into some of the possible applications that we can use to enhance our lives. So my second message I want to share today, that is I want to share some of the ideas that we can do by analyzing daily activities, logs. The first one is we can recognize the current context and retrieve the similar known cases. For example, when you arrived into a new city, maybe you don't really know which the building is, what you can do in this building, and where the museum open, and can you have any room available in the hotel. So you can use the landmark recognition. The traditional way to do this, you can use GPS information, and you just look around to see we are looking at this one, and we can have several services to be provided at this location. However, we can use the augmented reality together with computer vision to recognize with more accurate result at different locations just by looking at the picture. Traditional approach can be using banks of words, visual banks of words, and retrieve the result. Then you can have enhanced version of this one to do, or you can use deep features to enhance the final result. However, this one is still a challenging problem. In CVPR 2018, we also have the Google challenges for landmark recognition and landmark retrieval. That means this problem is still an open and challenging problem if you want to deal with real data set with huge amount of photos in them. We already listened to Huing's story in this morning that she mentioned that you try to take part in the challenges, something like cargo. This is a very good way for you not only to demonstrate your skills, but also to learn in depth how we can control and manage the algorithms and deal with the practical, real problems. We just built this one. This one, I just put it in this one because I want to show some link with what talk we already listened. Of course, face recognition and face detection is very, very interesting, and it was considered for many years. However, it's very challenging problems because we have different conditions for lighting, illuminations, pose, and different things like that. And of course, with GAN or domain adaptation, we can boost the result, right? We can give the one for short. And the next one, every day when you have dinner or lunch, we usually take photos. Not selfie only, but take photos. I don't really know if you're really concerned about the calorie you consume or about the health. This is a hobby only. But if we can enhance the feature not only by taking a photo, just for fun and posting to Facebook and share and wait for your friends to like, then maybe you can analyze what type of food and is there any ingredient that is allergic to you and the calorie you consume every day. All of the demonstration I show with you today were developed by students. And this is what I want to say. The students, Vietnamese students in Vietnam, they could study and they could develop something fancy like this. But they really need someone to help them to get better knowledge and understanding. So I really hope that all the experts from the US universities and other famous universities in the world will help the Vietnamese student by getting closer to the level of international standards. This is all to demonstrate what the student in here they can do, but they can do more and successfully. For example, you get the name of the Khả family, something like Khả Ái, Khả Nghịch, and I don't remember the last name. I just know their names, the real names, because they are just in the same class of the same university. But now they just use a different nickname like that in this morning to win the very first prize and very high result with the group of Viet AI, right? That is one demonstration of what the student can do. And I want to use this one because Triet is among the very first speaker of the AI talk, maybe in July. And he is now in Google Praying, and this is his bachelor thesis using regression for counting and visual attention. I just skip this one. We don't really need to do with this one. The next possible types of application we can do is finding lost items or retrieving and verifying the memories. When we understand the context, we can easily find a moment of interest. I just put my laptop or my smartphone somewhere. I just want to look back into the memory and say, hey, the last time I saw this is about 10 minutes ago, and I can retrieve the location. I just go back into the location and get my object. This is good. Of course, I must have a dedicated wearable device to capture every moment in our life, and we should consider for the battery and energy usage in that. But if it can be realized, this is good. Okay, when I try to retrieve the photo in my smartphone in the dinner with Hoa in June, right? In June, I need to scroll down in the album of my cell phone just to search for that. If I can explicitly input my query in some convenient way, I can say I just want to retrieve a photo with this guy in the dinner in somewhere, and we add something like this, and we can automatically retrieve the short list of the possible candidates. It should be better. So this is the second type of application I want to share. Live logging data. We can have something like photos. We can also have biometric information, the heart rate, the glucose, the blood pressure, and things like that. And how we can input the information in that if we understand all the context. In our system developed for RCRA 2018, we have the following components. The first one, we have the place recognition to localize this one first. The second one is the action detection. We use the image captioning to get the verb or the action of interest in one photo. And we also have the entity detection for different names of known persons or even for different known objects of known categories. And then we mix all together to provide a system in order to help people to input. However, this is only at the very first step to develop. For example, we can have visual clustering for images to group different photos in the same room or location. Then we try to detect different objects of interest. And we can also, because now we have a huge number of open source systems that you can apply, you don't really need to train from scratch, but you can apply to get different components to be available for you. For example, you can see in here, we can know this photo might be taken in the home theater or coffee shop or fast food restaurant and car interior. The interesting thing is that we don't really need only the prediction result, but we need a way just to persuade ourselves to trust the result. In here you can see the heat map or visualization of activation. In this case, we say, okay, I get this prediction result because I focus on a certain area and get the final prediction result. So not only to get the result, but we should try to explain why it should be trusted. And if you get a wrong conclusion in here, then you need more data to train in order to help the system to be better in the future. This is one way. For example, in this one, we try to find certain event by building a chair that is good in late afternoon and in the office environment and different things like this. Currently, our system cannot understand this one directly. We need human user to process this one and extract main things and use the system to retrieve certain events. We cannot do this in our group right now. We just close this one. And to detect certain events, we may exploit the image captioning. That means we try to get the caption to be generated on the fly from an image. Of course, there can be different levels of details that we can generate. We have general description, we have the very detailed one. And in this case, our system, our method, try to focus on different areas so that we can verify whether this one can be reliable or not. If we don't have enough data, get more and train. The next one. Okay. We usually post photos to Facebook, and we love to see something on this day, 10 years ago, 5 years ago, or things like that. However, do you have any questions, something like this? On this place, not on this date. We can retrieve similar scene in the same place. Maybe you can find your friends when you go back into the high school. Not necessary to be at any specific day. We just be there in the location and we retrieve the photos in there. So we can use image retrieval in this case. Or maybe if you are there, maybe you can find your photo in here. I just want to borrow some of the members in Viet AI teachers that is in his bachelor thesis. And he tried to have the automatically annotation by adding the similar text from the given text in one image by finding the similarities. The next one, traffic analysis. Okay. In this one, we have the video clips from the challenge in NCVPR 2018 for detecting the vehicles as well as the velocity estimation. And we also have the topics for anomaly detection in this case also. If we need to detect vehicles in different contexts in the blurry environment, very far away in tiny objects or things like that, our proposed method in this case is we have different profile in this case so that we can adapt into different scenario to enhance the final result. It can be used also for the case when we want to have people with better prediction. In a supermarket, we count how many people are there, and then we can easily allocate different resources to enhance different slots. And the last thing I would like to share, that is the simulation in virtual environment. This is our paper in VRSG 2018, last month in Japan. We try to help people to learn how to survive in the traffic, especially in Vietnam, very dangerous one. And we try to simulate the events from the real life. We detect vehicles in real life, we track the velocity, and we generate the simulation in the virtual environment from the real scene. We try to combine two different aspects, one in computer vision and one in software engineering and virtual environment. This is something I want to share with you in the next message. We need the real problem. We need the convergence of different research topics, not only in algorithms, but we need to apply into applications. And we can also synthesize different scenes from the real life. Visual object segmentation can also be done if you want to generate more data to train, especially for different contexts. This is what we do last year, and then this year we try to take advantage of the human pose to enhance the visual object segmentation this year. You can see that in this case we can track multiple objects, multiple person instances at one time, and it can follow the people, and it can also assign very precise boundary even when we have the very quick motion like this. The next one is that we can use the robot to scan 3D objects. It can move around as a robot, but we can only get the partial view of the object in RGBD information. So how can we complete the information, or we predict which object we are looking at, which area we are in? And then maybe we can also replace the partial object with the very ideal design object like this. So it can be some proposed method if we get the multiple views surrounding the object, and we use attention mechanism to focus on the area that can be reliable for the prediction. For example, in here, we have one object and we can get multiple views of the same object from different viewpoints. And we try to evaluate which view might give you higher score of prediction in that case. And finally, we can create a system in which we replace the real object with the virtual object, so we can try different layout in the room in a virtual way. So for the conclusion, I just skip this one. This is the last message I want to share. Computer vision, machine learning, AI, hot trends, yes. But we need to make this one to become a real application. So we need skills from software engineering experts. Maybe in this afternoon we can listen to Kenneth's talk. I just want to introduce you first. Your talk several months ago influenced my thoughts a lot. Thank you very much. Because you try to show how we can combine between the mindset of software engineer and AI researchers. Thank you. So I just want to bring this one in the same thing. But there is one more aspect we should consider, that is the human-computer interaction factors. Very smart system, very fancy function, but people might not accept the way you provide for interaction. It cannot be accepted. So I think we have the algorithms first. We have how we can develop into the real application, but we need to fine-tune the way for interaction. Only then the system can survive and get people to know, to use, and to live with it. So thank you very much.